Hello, this is Mr. Quinola, and I'm going to show you how to do a mixed problem with a 45, 45, 90 triangle and a 30, 60, 90 triangle. We know that this is a 45, 45, 90 triangle because this has to be 45. If we use the triangle sum theorem, these three angles add up to 180 degrees, and this angle has to be a 30-degree angle because if we use the triangle sum theorem, these three angles add up to 180 degrees. So let's look at this problem. Here's our destination. We're trying to figure out what x is. Okay, so this is where we want to end up, and let's look at what they give us. They give us this side right here, which is 7, and let's figure out what connects these two triangles together, which is this side right here. So let's just call this side W. Okay, so we're going to go from what's given to us and to W, and once we figure out what W is, we should figure out what X is. Okay, so let's start off with this first triangle right here, a 45, 45, 90 triangle. And if you remember what the pattern is for 45, 45, 90 triangles, okay, let's make this a 90. Let's make this 45. Okay, these two sides right here, another name for 45, 45, 90 triangles is an isosceles right triangle. If it's isosceles, that means this side and this side are congruent because this 45 is looking at this side and this 45 is looking at this side, so these two are the same. So let's call this side X and let's call this side X since it's isosceles. This side right here is the hypotenuse because the 90 is looking at, or this side is opposite to the 90 degree angle. So the pattern is whatever the leg is, which is X, you multiply it by radical 2 to get your hypotenuse. Okay, so looking at this triangle, this is a leg and the W is the hypotenuse. So we're going to take the leg, which is 7, and we're just going to multiply it by radical 2. So W, I'll put an equal sign right here, equals 7 radical 2. Okay. So we're done with this isosceles right triangle, and we've moved on to this 30, 60, 90 triangle. So let's look at this 7 radical 2. It's this side right here, and for this 30, 60, 90 triangle, it's the short side. So let me draw a 30, 60, 90 triangle. Okay, so there's that, here's this, here's 30. And here's 60, and let's review the pattern. Okay, this side right here is the short side because it's opposite the smallest angle. So the short side, let's just call it X. Okay, and this side is the middle side because it's opposite the middle angle, which is 60. So the middle side is whatever the short side is times radical 3. And this is the hypotenuse because the hypotenuse is always opposite the 90 degree angle. To figure out what the hypotenuse is for 30, 60, 90 triangles, you take the short side and multiply it by 2. So it would be 2x. So the hypotenuse is twice as long as the short side. So let's go back to our original problem. Here is the short side. We know it's a short side because it's opposite the 30. Which is 7 radical 2. We're trying to figure out what the hypotenuse is. So we'll take the short side, which is, let's use a different color. So let's use 7 radical 2, which is the short side, and we're trying to find the hypotenuse. So we're just gonna double that because the hypotenuse is double the short side. So we'll multiply it by 2. So 2 times 7 is 14. And this is a radical. We're not multiplying with anything because there's no radical out here to multiply this radical with. So it would be 14 radical 2. So there's our final answer for this problem right here. Let's do another problem. Let's look at this one. It's similar to the previous problem, but a little more challenging. So this time, we're going to, our destination is this X right here. Our starting point is what they give us, this 6 radical 2. And what connects these two triangles is this side right here. So let's just call it W again. So we're going to start off with the 6 radical 2. Go to W, figure out what W is, and then using W, we'll figure out what X is. Okay, so let's analyze this first triangle right here. This is a 30, 60, 90 triangle. Okay, so this angle has to be 30 again. Using triangle sum theorem, this has to be 30. So this 6 radical 2 is opposite the 30-degree angle. So this is the short side. And this W is opposite the 60-degree angle. So this is the middle side. So let's go back to this right here. So using the rules for 30, 60, 90 triangles, if you have the short side, you can find the middle side by multiplying the short side by radical 3. So that's what we'll do over here. So we have our short side, which is 6 radical 2. And let's figure out what this middle side is by multiplying it by radical 3. Okay, so just like the pattern, we take the short side. To get the middle side, we multiply it by radical 3. So we don't have a coefficient on the outside, so we'll just leave it as 6. And then we'll multiply these radicals with each other. So radical 2 times radical 3 would be radical 6. Okay, so W equals 6 radical 6. Okay, but we're not done. We have this middle side. We're trying to figure out what this side right here is, figure out what X is. So let's look at this triangle. This is a 45, 45, 90 triangle. We know it's 45, 45, 90 because these two angles are supplementary. So we can make this a 90. And using triangle sum theorem, this is 90, this is 45. Well, this has to be 45 degrees also. All right, so we know another name for 45, 45, 90 triangle is an isosceles right triangle. So this side and this side are both congruent because it's isosceles, but we're trying to figure out what this hypotenuse is. So let's look back at our notes from the previous problem. 45, 45, 90 triangles. So we take the leg, and to get the hypotenuse, we multiply it by radical 2. So let's take our leg, which is 6 radical 6. And in order to figure out what the hypotenuse is for the 45, 45, 90 triangle, we multiply it by radical 2. Okay, so we're going to multiply the radicals together, which is 6 times 2 would be radical 12. Okay, and we don't have anything to multiply this 6 by, so we'll leave it as 6. So let's look at this 12. If you notice, we can factor this out, and when we're simplifying radicals, we have to find some pairs. So let's factor it out and see if we can find some pairs. So what are two numbers that multiply to 12? Let's try 4 and 3. Can we factor out this 3 anymore other than 1 in itself? No, it's a prime number. Let's look at 4. We could factor out 4 some more to 2 and 2. And so let's find some pairs. We only care about the bottom parts of this tree, or the leaves of this factor tree. So the 2, and the 3. So we have a pair of 2's right here. So we're going to circle it. We have one pair of 2's, and we have a leftover 3. So if we just simplify this radical 12, it would be a pair of 2's. So the one pair of 2's would be just 2. Okay, and then the leftover is radical 3. So radical 12 is equal to 2 radical 3. Okay, and then let's bring down the 6 down here. Okay, let's not forget about that 6. So let's multiply the 6 and 2 will be 12 radical 3. And there's your final answer. All right.